Hello, this is an update to my Starship Mag Motor, Part 2. Did a lot more work last night to clean up. I had everything breadboarded on the circuit, which I had right here, and I figured it was time to clean things up and get things permanently on the board for a working circuit. And that there, of course, replaces this and will be placed into a small aluminum box. This, of course, is all the wiring. I finally got my, I had the NE3055 transistor hanging near the floor. I finally got that hooked up to this with the heat sinking and all the necessary connections for that. And so I could free up a lot of my test leads so I could use them for permanent monitoring. So I wanted to kind of explain a couple of additional things I come up with. And anyway, and here's basically, this was seen before, but here's the the meter showing the frequency that's being generated. Of course, we're almost close to 20 hertz, as it translates out to 20 pulses a second. So you can figure out the RPMs from that. Anyway, also I have a meter here, of course, which is hooked up to there's only two coils, of course, that are driving the whole circuit. So one of these transistors here are actually being used to drive, I believe, this coil and this other coil, which I have a wire going back to. Now, incidentally, I have these other LEDs here. These are not hooked to anything except the coil. That's just demonstrating that the coils individually are actually generating some kind of power. Not much in their essential form, but they are enough to light the LED. And one of the things I discovered in looking at the circuit was I was trying to figure out, and really I don't know why it didn't occur to me. We're looking at all the videos from different folks, but you know, when we start talking about the subject of back EMF, I didn't really fully grasp the concept until it struck me yesterday, and I was actually looking at my scope right here. Now this is a scope reading of the emitter of the main pulsing transistor, which basically, as I explained before, you have a Hall effect transistor here that's actually reading the magnetic magnets as they pass over it, and there's a certain, what they call a sweet spot, to activate the coil to give them enough push to push the magnet forward. So basically this is the Hall transistor controlling that. And as I said, it was 18 pulses a second, or 19 pulses a second approximately, or 20. If you notice, one of the things I noticed is on the edge of change. If you look at this, of course I have moved the positioning, so if I pull this down a little bit from the center line is ground, and there's a slight negative dip. And then there's a major change where the Hall transistor is actually turning on and activating the coil. But the point of change of the coil, you'll notice that there's this little spike of energy right on the top part of that beginning curve. And I looked at it, of course it's not as evident right now, it's very faint, but I did notice it. And this was the infamous back EMF that people were talking about. And the reason I was concerned, because I pulled my signal way down here. Can't see it as well on the scope here because I actually got this hooked to a cap. But I noticed that spike, and no matter how many divisions up, it was shooting all the way up to almost past 50, 60 volts or whatever. So, and of course my meter wasn't going to, my digital meter, voltage meter, wasn't going to reveal how much energy, because it tends to average out the total voltage. So what I did was, since I got two of the power coils hooked up in parallel together, I decided to take a rectifier, just a regular little silicon diode rectifier diode and basically start rectifying the negative pulses, and then feed that into this, which is these are extremely large can type of capacitors from God knows how long ago, 50 years, 40 years ago, from some of the old equipment. This is surplus equipment from probably Army. But anyway, I forgot how much total capacitance. I think there's a total of 6 microfarad or something like that. But they're rated about 300 volts. So I got both of these in parallel, hooked together. And so I took the leads from the rectifier and went to one end, and then, of course, what it perceives as ground on the other side. And the nice thing about capacitors is if you're trying to look for a top spike or top voltage that the thing is actually trying to spit out, not look at the average voltage, this is a good way to do it. So you hook, so basically I hook that up, and then I decide to go ahead and monitor it. Well, turns out that spike, here's the meter that's hooked up to that, and I'm driving this thing with 12 volts, and the negative back EMF is, according to the meter here, going, looking at the caps, of course, is about 73 volts of back EMF. Now, that's not a lot of power in the pulsing itself, and a lot of that I mentioned is attributed to the fact that I have not hooked up to the circuit any 555 timer circuit or anything like that. I have a separate circuit that I was working on, or similar, right here, that's going to be used to pulse at an incredibly fast speed while the Hall transistor is actually activated. So the pulses actually generate the spikes, or the back EMF spikes. So the faster the pulsing while the coils are activated, then the more frequency of those back EMF spikes, and which translates into not just voltage. Your concern is about duty cycle or power, which results in increased amperage. So that's what we got to do. But this is just simply demonstrating right now that it is possible to collect a huge negative voltage. And based on the fact I only have 2 of these coils, really, they're not even in series yet or anything. Logic stands that if these were hooked up in series, that you have a greater potential, which results in a greater potential for back EMF, and that would result in even a much higher. I know HHO for volts has had his coils hooked up where it actually spiked about 400 volts or something of that nature. So that's going to be my next step. Last night was all about cleaning up and getting things where I don't have a million leads tied up in here and no permanent circuit. So, and I still got more wiring to do, and I got 3 more coils to build too. So I'm pretty satisfied. These coils are fantastic. They run about the windings, of course, wire windings are approximately enough where there's they're bifilar hooked up in series, so there's about 10 ohms total, which is more than enough amperage if you're able to raise the voltage, and that's what we're attempting to do. So once you get this thing up to 80 to 100 volts, then 10 ohms, still you're talking about being able to produce 10 amps out of that kind of power. So anyway, we're going to leave it at that. I believe I only have 10 minutes on YouTube to be able to post video. So that's the conclusions I'm coming to, and I'll keep updated on the next video on my progress. Okay, you all have a good day. Signing out.